So we are going to discuss today that OSI model and TCP/IP. So first of all, we need to remember these layers. So starting from top, that is application, presentation, session, transport, network, data, and physical, right? And we are not actually using OSI model in real networks because OSI is a reference model. This is the reason model is known as reference model, just to understand about networks and how actually packets travel from one source to destination. We actually learn OSI model. Even in the Cisco books or even any vendor books, you will understand OSI model first. And in real world, we are actually using TCP/IP. So the combination of application, presentation, session layer is application in this TCP/IP, and in transport we say transport, the same in TCP/IP also. Here we have network, here also we have network, and the combo of data link and physical, we can say that network interface. But now the TCP/IP is also updated. It means, data link layer is known as data link layer and physical is known as physical. So earlier TCP had four layers, but now we have TCP IP updated version in which we have five layers. First is application. Okay. So that is transport. We have network, we have data link layer, and last we have physical layer. So in nowadays in TCP/IP, we can say that we have around five layers. Application, which is actually the combo of these three layers: application, presentation, session. So when we want to learn IT networks, then we always learn with the OSI model. And if you understand OSI model, then TCP/IP will be very easy to understand. Okay. So we'll be starting with the OSI model, and then we will go with and check TCP/IP also. Okay. So, but yes, we need to understand first this OSI model. So there is a alliance to learn this. Like all people seem to need data processing. Like all people seem to need data processing. Or you can say that please do not throw sauces, pizzas away. So it's just allies so that you can understand or learn the layers in order. Okay. So what? So every time when we learn about IT networks, there is a term called protocol. So what is this protocol means? So protocol means a simple set of rules, right? A protocol is known as set of rules. Like suppose you are driving a car, you need to follow some rules, right? So the government of that particular country is already made some rules that you need to drive or at the right side or the left side, right? So there are rules, right? So the rules we have over the internet also, these rules are actually known as protocols. Like when we say transport, TCP, IP, or these protocols. So these are actually rules. If anybody wants to go over the internet, they need to follow the rules. Like all Windows machines, all MacBook, or all routers, which is all are following the same rules, that is TCP, IP. So what I was saying, so like to reach internet or to follow, so OSI model, TCP IP are rules so that we can follow the internet rules. So these are known as protocol. So like all these 4 5 routers are sharing the information with each other, so they are following some rules, right? So these rules are actually known as protocols. Okay, let's come back to OSI model now. Okay, so that was just a quick reviews if anybody joined session from today onwards. So yesterday we have covered these things like network fundamentals, router switches, and all. Yeah. So let's start with the application layer. What will happen and what exactly this layer means, application. So application means any softwares which interact one human to another is comes under application layer. Like your web browser uses HTTPS protocol, right? So when you use HTTPS, when you are sending email, telnet, or so all these protocols comes under application. Okay. Yeah. Okay, so there are many protocols I'll discuss in detail. Okay, these application, but just understand, if anybody wants to communicate with another user, from if one human to another, you can say that. So they are going to use something, right? You want to access website, you will use HTTP or HTTPS. You want to send a email, you will use simple mail transfer protocol to send a email. To receive email, you will use POP, Post Office Protocol, or there is another protocol, IMAP, Internet Message Access Protocol. So these all protocols are used by emails so that you can send or receive the emails. So these two protocols are used for www, World Wide Web, so that you can access the websites, right? So there are a lot of protocols which falls under application layer. So whenever, like file transfer protocol, to send files to the server, we use FTP. Okay, so these protocol, and if you want to access any device remotely, so you are in India right now and you want to access a router which is in USA, right? So you are in India, so you are working as a network engineer for any US company from here. So you can directly access the router from here. Okay, so that is Telnet, and there is a secure version of it that is known as SSH. So that is for to remotely access the devices, right? Yeah. So these all, if you see from application point of view, all we are doing, we are using these application for sharing data. So we are accessing the websites, we are sending emails, we are sending files, we are actually accessing the router switches or maybe the servers from internet. So these all falls under application layer. So any softwares or any protocols which interact one human to another, or maybe you are interacting with any protocol, or you are sending data somewhere, so you are actually false, these protocols comes under application layer. Okay, so now the second one is, or you can say the sixth layer, because seventh is a application layer from top to bottom, sixth layer is presentation layer. So what does this presentation layer do? So presentation layer actually tells about the format of data. So what is this format of data? So format of data means when you see a web page, either it is a google.com, youtube.com. So let's suppose youtube.com. Okay, so you see images, thumbnails of videos, you are watching a video over here, comments and all. So the data you are actually seeing right now, so the data is coming from YouTube server in the form of some code or some HTML or some type of format, but it is actually showing you in your format, right? So because directly video is not coming, so maybe the URLs or maybe the links of videos are coming, so that it is keep the video is going to buffer from the servers, right? So what I'm trying to say means the data you see on your screen is actually uh, converted, or you can say that this presentation layer helps us to show the representation of data, or the like images in multiple formats like PNG, JPG, audio is in multiple formats, video is into multiple formats. So it's a presentation layer responsibility to show the data in the correct format so that you will understand. Okay, and it is also responsible for this encryption, decryption, because if you want to encrypt any file or folder, the presentation layer is responsible. Again, this is a reference model to just understand, but in real world all comes under application layer, because all three layers all three layers, right, is known as application in real world. So when you say in real world, the format of data is actually taken care by application layer. Okay, But here when we discuss a OSI model, it falls under presentation layer. Okay guys, so when now the data is also this in this presentation layer is also responsible for compression and decompression, means to reduce or increase the size of the files. So these two layers done, right? So applications means the applications which interact one human to another. In presentation layer, just remember the keywords. Just remember the keywords. The keyword is here, the applications or the software which interact one human to another, or maybe you can learn the protocol names. And in presentation layer, the keyword is format of data. So just remember the format of data. So when the data is moving to session layer, so session layer is actually creating and maintaining the sessions. So whenever you open any bank website, right, so it has a time limit. So if you don't use your like if you are away from keyboard like for almost 5 minutes or 10 minutes, right, the session will automatically log out if you are not using your screen or you are not using mouse pointers or anything. So the session will log out automatically. So why? Because this session layer is controlling that time frame. So whenever a developers actually makes websites or applications, they actually code that time frame with the session layer algorithms. So suppose if I'm uh, okay, suppose I'm using one bank, suppose HSBC bank. Okay, so in this bank, I'm not using this screen for almost 10 minutes. So HSBC website is actually coded with by developers. It it's integrated with some session programs. Like the session will log out after 10 minutes or maybe 15 minutes. So all falls under this session layer. So session layer means the time frame in which the session will be controlled. This session layer actually create and maintain the sessions with the time frame. Okay, so all three layers clear. So application means the softwares or the applications. In this we actually takes care of format of data. This is the keyword. And in session layer we actually create and maintain the time frames. Yes guys, nobody is responding in the chat. What happened? Hello, hello. Okay. SNMP will discuss, that is a network management protocol. Okay, great. Okay, so all three falls under these three, and all three layers are in real world, they are known as application layer. So you will not find actually presentation layer or session layer or application different in real world, because in real world all falls under one layer, that is application. Okay, clear? Hmm. So now this is very important layer of, so that is transport layer. So now when we discuss about three layers, so the data is in which format? Data. So now when the data comes to transport layer, it actually converts the data into segments. It means it will divide the data into multiple chunks or parts. So whenever from above layers we are getting data, and transport layer is actually converting these packets into segments. Okay, means you are getting a data. Okay, suppose this is data, not just hello, I'm just giving an example. So when the data is going to transport layer, it is actually segmenting the data into multiple parts like this. So again, hello is very small, so I'm just explaining you what is happening. So the data is actually converting, and so this is known as segmentation. Okay, and also this transport layer is responsible for sequencing. What is this sequencing? So it will actually add the number on the data. Why? Because when data is going from one PC over the internet to any another device, uh, over the internet or in your LAN network anywhere, so the data is traveling, so might be there is a chance the packet will be drop. And when the data is going to B, so B will check, okay, I got 1 3 4 5, I haven't received the second number sequence, can you please retransmit, can you send me again? So in this transport layer we actually do retransmission also. Okay, so transport layer is responsible for multiple things, so like sequencing, segmentation, retransmission, all this stuff. But transport layer actually divided into two protocols. So all this retransmission, segmentation, sequencing all comes under TCP. Yes, Nikhil, correct. Sequencing is used so that we can assemble or reassemble the data at the destination end. Okay. So that is the overview. Now let's start transport layer. Okay, so in transport layer, I have explained you the data is divided into segmentation. But before doing that, so the now data is coming from above layer. Okay, so now you can just say that we have, so the data is going in, we have two trucks over here. So one truck is known as, you can say that it's a TCP and this is a UDP. So now data, either if data is going with this truck, what will happen? So whenever we send any data with TCP, whenever, so this, any packet is going from source to destination. So the destination is going to send us back a receipt that is known as acknowledgement. Means if the data is going with this guy, okay, it is going to take, or it is going and coming back with the receipt that I have delivered the data. But when data is going with this, with the UDP, we are just sending the data, but we are not going to get back the receipt of whatever we are sending. So it means whenever we send data with the TCP, so TCP stands for Transmission Control Protocol, Transmission Control Protocol, and UDP stands for User Datagram Protocol. So whenever data is going with TCP, so it actually takes care of acknowledgements. So tell me, if anybody is coming with the receipt, who is more reliable, TCP or UDP? Because it is coming back with the receipt that I have delivered the data, so this is reliable. Where this person or this UDP truck is not reliable, right? And if data is lost, if suppose we are sending data, one box dropped somewhere in the road or somewhere, so the vendor is actually take or count the boxes, how many boxes we got, right? And it actually says, oh, please send me one box again, or maybe the box is broken or something, so it is going to retransmit the data. So we don't have any retransmission over here, no retransmission. So if data is dropped or discarded or anything happened with the data, it is going to retransmit the data, right? Yeah. So this is known as, it always believes in connection. So this is, in network language, it is known as connection oriented, because it always believes in making connection, but this is connectionless. right? So UDP, so there is a term called fast in UDP, but nowadays our internet is super fast, so we don't have to say that TCP is slow or fast or something. So you can skip this line. It looks like very childish if we speak like this is fast or slow like that, because now yes, you can say yes, correct. So you can say like one guy Sharath has given a very good answer. So it has less overhead. Less overhead means whenever we sending data, we don't actually send a lot of many things. So it means there will be less size of the packet in comparison to TCP. So TCP takes 20 bytes and UDP takes how many bytes? I think 8, right? 8 bytes. So any data, any small box or any packet going with UDP, it is going to take 8 bytes, and in TCP we are going to take, on every packet I'm going to place my address, that is 20 bytes. Yeah. So TCP, there is a protocol number to it. TCP protocol number is 6, because these both protocols falls under IP. So IP is the biggest or main protocol. So TCP works under IP and the protocol number is 6, and UDP works also under IP, that protocol number is 17. Again repeat, okay. So see, in transport layer we have two protocols, TCP and UDP. So whenever we send data from TCP, we always get acknowledgement. Here we don't get acknowledgements. So this is the reason it is reliable and it is not reliable. So whenever anything happens with any packet, it is going to retransmit it, and here we don't have retransmission. So this is the reason we also say that it is connection oriented and this is connectionless. So TCP takes 20 bytes to add information and UDP takes only 8 bytes to add the UDP information. So what is that information? That is port numbers. We add port numbers here. So the bytes I'm talking here, 20 bytes, 8 bytes, it actually adds port numbers. Okay. So suppose you are sending data from your computer. So computer is going to add one port, and destination port will be like you are going to HTTPS and all. So it is going to add the port number. So we will discuss this also. So just understand this in transport layer right now. So connectionless means, connection oriented means it all believes in connection making. It is going to retransmit it, and it always means, connection oriented means it always believes in making connections. Connectionless means if anything happens or packet has dropped, we are not going to retransmit and all. So this is the reason you can say that it's connectionless. Yeah, not trusted. Yeah. So we don't, this is not reliable or not trustworthy. Connectionless is just a synonym of this, you can say the reliable. Okay, so what we have learned so far, the data is coming, and data is coming to transport layer is actually converting those into segments, right? So which layer is converting? Transport layer. Okay, so now the data is moving to which layer? Network layer. So now segments is actually converting into packet. Means the data is here. It's like a gift trap, you can say that. Data is here. So on top of it, we are going to add extra header, that is like source port number. Okay, source port number, destination port number, and this whole is known as segment. So that is known as encapsulation also. So whenever you add something, that is encapsulation, or whenever you remove something, that is a decapsulation. Okay. So data is actually going inside a segment, and now on top of it we are going to add a extra few things, that is known as now packet. On top of it we will have another thing that will be known as frame. Okay. So packet will have source IP, destination IP, and frame will have source MAC address, destination MAC address. There are a lot of, okay, okay, so I'll explain in more appropriate way. So I'm just giving you idea. Yeah. So packets. So in network layer, all your routers and all works under this network layer, and packets actually adds the source IP and destination IP. So whenever we talk about the IP address, this segment actually adds the port numbers, and in packets we add the source IP, destination IP. End-to-end delivery means it is going to take care of all the responsibility of sending data from source to destination, because the transport layer is choosing which protocol is going to carry forward your data. So this is the reason we have written here end-to-end delivery of data. Okay. So packets is now moving to another layer, that is packets are going to convert into frame, and this which layer is doing this? Data link layer. So data link layer, or like in network layer, your routers works here and switches works on this layer. Okay, and frame is actually adding what information? Like in segments we have port number, in packets we have source IP, destination IP, and in the frame we have source MAC address and destination MAC address. Okay, and all your frame is now going to convert into signals, because your computer is going to send data, right? So all data is going from top to bottom. So now just see from this is a computer. So just understand this is a computer. Now physical layer means your NIC card is going to convert into 0 and 1 form, that is known as encoding. Encoding means converting, or encoding, decoding is converting the data into 0 1 format and converting them into signals, so that this computer is sending data to another computer. Okay, so this whole process is known as encapsulation, and also the data is going over the cable now. And whenever the second device, which is over here right side, you can't see, just understand, or we can place here, just hold on. Yeah, so now data is coming into another PC here. Let's take example. So now data is going 0 1 form again. Here we have physical layer, so we got 0 1s. It is now physical layer is giving data to data link layer. So data link layer is actually converting this into frame. It will check the MAC address information. Okay, so computer will check its MAC address. So this computer is suppose B, this is A. Okay, so when we open this frame, we get what? Packet. So when we in packet, we will check the IP address. So the packet is for my device or not. Okay, if a device IP address or the packet IP address match with this computer address, it means this is this computer information, this packet came for this computer only. So packet, when we open the packet, we will receive the segment. In segment, we will check the port number, which application this computer is trying to access, which application. And when we open the segment, we get what? Data. So this is how it works. Okay. So now let's revise again. So I told you application layer. What is the keyword? All applications. Like you can remember with the one human to another human, or you can remember with the keyword all applications, or like HTTP, SMTP, all comes under as this. Okay, application software which help interact one human to another human. Okay, very basic. So in presentation layer, what was the keyword? Format of data, right? Format of data. So when we talk about the like uh, compression here, compression, decompression, encryption, decryption, all falls under in this layer. So when we go, the data is going to session layer. So what is the responsibility of session layer? Create and maintain the session. Create and maintain the session. Okay. And when data is going to transport layer, so transport layer is responsible for end-to-end delivery of data. Means it is going to take care of all the delivery part, end-to-end delivery of data with the help of two protocols, TCP and UDP. So where TCP always send acknowledgements, where UDP does not send acknowledgements. So TCP has a sequencing, okay, put down the number over the packet, okay, segmentation, divide the data into parts, retransmission. So all falls, all these work under transport. And now the data is moving to here. The data is known as data. So now data is known as segment here, right? So now the data is moving to which layer? Network layer. So where we are going to add what? Add IP address. Here we are going to IP address. So IP address, either it would be IP version 4 or IPv6. So network layer is going to add the IPv4 or IPv6, any which you are using. So in data link layer, we are going to add what? Add MAC address. So MAC address means the chip hardware address of NIC. Okay, and the physical layer is actually converting your all data into 010101. So that is encoding.